Right. So, my dear children, on the earlier chapter we discussed about the magnetic poles, and we discussed that there are some certain magnets which the poles have been marked, and there are some certain magnets which the poles haven't been marked. Poles are not there, right? The poles are not being marked on the magnet. So, in this chapter, we'll be discussing how to identify the two poles of a magnet if they have not been marked on the magnet itself. So, we'll be identifying how to we'll be identifying the two poles of a magnet if they have been not marked, right? So, the first and foremost activity in identifying these two poles of an unknown magnet or else a magnet that has unknown poles is by using a compass. So here we can use a compass to identify the two poles of a magnet if they have been not marked like this. So identifying poles of a magnet using a compass. So we'll need these materials. First of all, we need a magnet that has unknown poles. Magnet that has unknown poles. So magnet with unknown poles. Magnet with unknown poles. And secondly, we'll be needing a compass. See, a compass. We'll be needing a compass. So in the previous grades, in grade 6 and also in grade 7, we have discussed that the compass is also a type of a small magnet. Compass is also made by a magnet. It's also a type of a small magnet which is at the center of this rotating part. At the center, there is a rotating part. So when you take the compass like this and we rotate it, the needle will also rotate. The needle will also rotate, right? So this rotating part is also a magnet, a small magnet, right? It can freely rotate around the compass. Okay. So compass is also having magnetic properties. So by using the compass, we can identify the two poles, right? So let's see how to conduct this activity then. So the method is really simple. Here what you have to do is you take the magnet that has unknown poles. You take the magnet that has unknown poles and you need to bring near this magnet towards the compass like this. Towards the compass, you have to take it near like this. Then you have to observe, which pole, right? Which pole? In the compass, there are also two poles. If you can see this figure clearly, there is an area or there is a terminal, there is an area, this is marked by red color. Can you see that? It's marked with red color. If you take any kind of a compass, the rotating part has been divided into two portions from the middle. One portion is colored with red while the other is with a different color. Most of the times it is blue, right? So here also you can observe that red color part. So this red color part is the north pole. This is the north pole of that area or that region is the north pole, right? So this end shows the north pole of the magnet which located inside the compass, right? This is the North Pole. I told you that compass is made from a small bit of a magnet which is getting freely rotated around it, around the magnet, around the compass, right? Around this structure of the compass, that small magnet is getting freely rotated. So this red color area shows the North Pole. Then the other is the South Pole region. So when you bring near this magnet, one of these poles should attracted towards the magnet and the other pole should repel and should travel away from the magnet. Okay? So the pole or the end which the North Pole is getting attracted. Now in this figure, you can observe if this red area is the North Pole, then this blue area, so this blue area or this the other region, this area, this is the South Pole. So on this figure, you can see that, on this figure, you can clearly see that, right here, you can clearly see that. I'll erase the things given in here so that you can clearly observe. So here, this is the South Pole and South Pole is attracted to this end of the magnet. This unknown magnet or the magnet that has unknown poles, I'll name the two ends as A and B. So this B end has attracted to the South Pole of the compass. This is attracted to the South Pole of the compass. Means this B end, you know that if you take two magnets like this, if you take two magnets, my children, north, south, I'll take another magnet and keep the north. Okay, and I'll take another instance like this, south and again south. So here you can see that north with north and south with south. I'm going to bring closer the two magnets in the separate two instances. So in these occasions you can observe a repulsion. In both of these occasions we can observe a repulsion. The two magnets will repel each other. It's because that these poles are like poles. These are like poles. Like poles means they have the same symbol. North with north, south with south. They have same poles. They are same poles. Like poles. So if they are same poles or else like poles, always these would repel each other. These would repel each other. You know this thing in earlier grades, but I'm remembering you once again, right? So if you keep opposite poles together like this, north and south, north and south, or else south with north. So in these situations, if you take an observation in these situations, we can observe an attraction. In these situations, we can observe an attraction. But in these two situations, we can observe a repulsion. repulsion, right? Attraction and repulsion. So you know that like poles or same poles, they would repel, and unlike poles, they would attract. So by using this observation, we can observe, or we can conclude the two poles of this unknown magnet. This B end is attracted with the south pole. This is the south pole because you know that red color area is the north pole in the compass. The earlier lesson part, I told you that if you take a magnetic pole, most of the times the north pole is being marked with red color. So this red color indicates the north pole, this indicates the south pole. So the south pole has been attracted to B. South pole has been attracted to B end. So we know that attraction occurs, we know that attraction occurs in different or else unlike poles. So if this thing is south pole, if this is south in the magnet, I'll name that thing as capital S. So if this is south, then in this unknown magnet, this one should be definitely a north. That pole should be a north pole. It's because that attraction occurs in not in like poles but in unlike poles. So if this is the north pole, we can say that A end is the south pole. So this is the south pole then. See, it's really simple to identify the poles of a magnet, unknown magnet, by using a compass. You just need to bring the magnet closer to the compass and observe which end of the compass or which terminal of the compass that is getting attracted to the unknown magnet. So observe that end clearly, and the opposite end or the opposite terminal is the one which is on the magnet, right? If you know one certain end, what's the pole of it, then you can find out the pole of the other end. So this is how to conduct this activity. So we'll see what happens or how we can identify the poles of an unknown magnet in our laboratory, right? Right, my dear children. Then we'll see what is the method, or we'll write down the method in conducting the activity. So this is the method then. Bring the magnet near the compass and observe the attraction or the repulsion which occur with the terminals with the terminals of the compass needle. So first of all, we have to bring the magnet near the compass and observe the attraction or the repulsion which occur with the terminals of the compass needle, right? So we have to observe what happens, or we need to observe what is the thing which is going to happen when we bring near the magnet towards the compass needle. And we have to observe which portion or which terminal which is getting attracted or which is getting repelled towards the magnet or away from the magnet. So by that way we can observe the two, or else we can observe, or else we can identify the two poles of the magnet. Right, my dear children? Now let's see how to find out the poles of a magnet. So here we are going to find out poles of a magnet by using, this instrument is called the compass. So we can use a compass to find out the poles of a magnet. So here I have a bar magnet. And the compass. So I'm going to show you how we can use this compass to identify the poles of a bar magnet. So here you can see that the poles of the terminals or the two ends of the compass is showing north and south directions. So always a compass is going to turn for the north and south directions. If I am going to freely suspend this compass, or if I'm going to if I'm going to keep this compass on a free position like this. So now let's see. Here in the compass you can observe, in this compass here you can observe the red color. That means this is the north and the other terminal, then it is the south. So you know that in a compass we use a free rotating magnet. In a compass we use a free rotating magnet, right? So this is also a magnetic material. So we'll keep it like in here. And let's see how to identify the poles of a magnet. So now I have a bar magnet with me, and you can see this is the south pole, this is the south pole, and here you can observe this one is the north pole. Now what I'm going to do is I'm going to take this compass and bring near the south pole of this magnet towards the compass. Let's see what ends of the compass, or which end of the compass is going to attract towards the south pole. So let's see. So you can see that clearly, you can clearly observe it, right? When I'm keeping in this way or in this position, here this is the south pole, this is the south pole. South pole is attracting towards the red color terminal of the compass, means the north pole, right? So we can use this compass to identify the terminals or the poles of a magnet. Now if I'm going to interchange the two terminals, means that I'm going to now take the north pole. I'm going to take the north pole, right? I'm going to take the north pole towards this compass. You know that compass is also a magnet. So if I am going to bring near the magnet near the compass like this, right? the compass needle will change. See, it's rotating here and there. See, it's because that compass is a magnet. So direction of the compass can be changed, or direction of the compass is getting changed when a magnetic field, or when a magnetism is around, or when the magnetism is near the compass. See, so that's why I take this thing somewhat far. So here, this is my north pole. Then now I'm going to take this north pole towards the compass. We'll see what's going to happen. And now here you can observe that the south pole, or the terminal which do not show the red color, is getting attracted towards the north pole of the bar magnet. So we can come into conclusion that if you take any kind of a magnet and a compass, we can identify the magnetic poles. Only thing that we need to do is we need to take the magnet near the compass. So always remember, in a magnet, in two different magnets, unlike poles are the ones which are getting attracted each other. Unlike poles are always getting attracted each other in two magnets. So when I'm going to take this magnet near the compass, the opposite poles would attract. Here you can see that compass needle that do not show any color, or that haven't colored with the red one, is getting attracted towards the red color of this thing. And when I'm going to interchange, see, the blue color area, or the blue color terminal, is getting attracted towards the red color region of the compass. So by using this observation, we can find out the poles of a magnet. Right, my dear children? Now I have a magnet. See, I have a magnet. Here the terminals cannot be observed. Means that this magnet is a magnet that has unknown poles. So by using the earlier situation, or by using the earlier observation which we took when we took a bar magnet near this compass, so by using that earlier observation, we could find out the poles of the magnet given in here. So now what I'm going to do is, I'm going to take this magnet and I'm going to bring it closer towards the compass. So you can see that, see, it's clear to us. It's very clear to us. Here this terminal is getting attracted towards the area, or towards the end that do not show the color. So the terminal of the compass which do not show that color is the south pole. This terminal is the south pole. So you can see that south pole is attracting towards the terminal, or the end of the magnet in here. So I can conclude that if this terminal is the south pole, if that south pole is attracting towards this terminal, means that definitely this terminal should be a north pole. See, this terminal is the north pole then. This is the north pole. If this is the north pole, this other terminal, that's the south pole. So to make our conclusions, or to make our conclusions more accurate, I'll take this end towards the compass, and definitely this end should be attracted, or this end is going to attract the red color terminal of the compass. So we'll see whether this terminal can attract that red color terminal. of the compass. So I'm going to take, so this is my compass now. So I have taken the other end now in my magnet. Now I'm going to take it towards the compass. See, you can see clearly the red color terminal is attracting towards the pole of this pole of the magnet. So this pole is the south pole. So this is the south pole. If I'm going to interchange it and bring near, then the other terminal of the compass is getting attracted towards the unknown magnet. So this terminal then, that is the north pole. This terminal, that is the south pole. So this is how we can identify poles of an unknown magnet by using the compass. Let's see our observation and our conclusion from this activity. Our observation was when north terminal is attracted to the compass, when the north terminal is attracted to the magnet, south pole is going to repel. South pole is going to repel. When south pole is going to attract, north pole is going to repel. So that was our observation, right? So when north pole of the compass is attracted to the magnet, south pole repelled. South pole repelled. And vice versa, we can write when south pole of the compass is attracted to the magnet, north pole repelled. North pole repelled. So this was our observation. When one terminal or when one end of the compass is getting attracted to that unknown magnet, then the other pole would repel. When attracting the other pole to the magnet, the previous pole is going to repel. So this is our observation, right? This is our observation. So here, when north pole of the compass is attracted to the magnet, south pole repelled. When south pole of the compass is attracted to the magnet, the north pole repelled. So conclusion from this activity, the final conclusion from the activity is that we know that unlike terminals or unlike poles of two magnets would get attracted to each other. So if the north pole is getting attracted if the north pole of the compass, north terminal of the compass is going to attract to the magnet, then that end of the magnet is the south pole. It's because that, my dear children, opposite poles or the unlike poles are the ones which shows an attraction, right? So we can write in our conclusion first. If north pole is attracted to the magnet, if north is attracted to the magnet, if north pole, I'll use the north pole, right? So if north pole, if north pole is attracted to the magnet, if north pole is attracted to the magnet, then we know that terminal is the south pole of the magnet. Then that end is the south pole of the magnet. So always remember, opposite poles are the ones which is getting attracted. So south pole is getting attracted with the north pole of the compass. So if north pole is attracted to the magnet, then that end is the south pole of the magnet. Okay, then that is the south pole of the magnet, right? So if north pole is attracted to the magnet, so I'll use this thing, if north pole of the compass, that's more accurate. If north pole of the compass is attracted to the magnet, if north pole of the compass, I'll use the compass thing also, so you may not get confused, right? If right, if the north pole, if the north pole of the compass if the north pole of the compass is attracted to the magnet, then that then that terminal means the end, then that end or the terminal is the south pole. then that end is the south pole. So always remember, you have to remember this thing. What is that? The opposite poles are the ones which are getting attracted. Okay, opposite poles are the ones which are getting attracted. If the north pole of the compass is attracted, then that terminal is the south pole. Then that terminal is the south pole. So in the next step, next one, we can write like this. Our second point, we can write like this. If the south pole of the compass, if the south pole of the compass is attracted to the magnet, if the south pole is attracted to the magnet, if the south pole is going to attract to the magnet, then that terminal is the north pole of the magnet, and that is the north pole of the magnet. So remember, these two are really important. South pole of the compass is attracted, then that terminal is the north pole. Okay, these two things are really important. Always remember, opposite poles are getting attracted to each other. So if you take a compass, if the north side or the north pole is getting attracted, then the terminal of the magnet is the south pole, right? If the south terminal or the south pole of the compass is getting attracted to the magnet, then that terminal or that end is the, right, then that terminal or that end is the north pole of the magnet. Always remember these 2 points. North pole is attracted to the south pole and south pole is attracted to the north pole. So by this way, we can finally conclude the 2 terminals or the 2 ends or else the 2 poles of a unknown bar magnet, right? So this is how to find out or how to identify the 2 terminals. If you are to identify the 2 terminals or the 2 poles of an unknown magnet by using a compass, right? Now let's see another way in finding out the 2 poles of a magnet that has 2 unknown poles. Another way to find out the 2 poles by using another way to identify the 2 poles of a magnet that has unknown poles. So here we are discussing finding the poles of a magnet by considering the direction that a magnet turns when it is hung by a thread, right? So here we are taking that magnet, especially here we need to take a bar magnet. We are going to take a bar magnet, right? And we are going to hang it by using a thread on a stand, right? So you know that this is like a compass. This is like a compass. the mechanism of a compass is also like this. Compass is working, I told you earlier, the compass is also having a small magnet which can freely rotate around the structure of it. Right? There is a magnet inside the structure of a compass. That magnet can freely rotate inside it. So after the rotation, the magnet, the terminals of that smaller magnet would turn to north and the south direction of our earth. It will show the north and the south directions of our earth. So by using that principle or by using that mechanism, we're going to find out the two terminals, right? We're going to find out the two terminals of the unknown magnet. So it's really simple to conduct this activity. What you have to do, you have to take the magnet and hang it by using a thread. Then you have to keep it still so that it would rotate and finally align with a certain direction. Okay, so we'll see how to conduct this activity. Okay, so first of all, you will be needing these materials. You'll be needing these materials. You'll be needing bar magnet, with unknown poles. Bar magnet with unknown poles. Then we need a thread, piece of thread. Then we'll be needing a stand to hang this stand. So a bar magnet with unknown poles, a thread, piece of thread, and a stand. So these are the materials that we need to conduct this activity. So this is the method, right? This is the method. So let's see how to identify the north and south poles of this magnet. So it's really simple. You hang, according to the figure, you hang the magnet freely, right? You hang the magnet freely, then allow it to rotate and stop and align like this on two directions. Then you can observe that, then finally you can observe that the two ends is going to align on north and south directions. Like this, it's going to align, or it's going to turn to north and south directions of our earth. By using a compass, you can identify the north and south directions. You can keep a compass near to it, keep it near to this mechanism, not near, but keep it somewhat far, right? Don't take it to near. Then you keep it like this. Then you can observe. You can identify the two directions, north and south. Then after that, see to which directions would these two terminals turn. So you can clearly observe that these two terminals are going to turn to north and south directions. So this is the method. Then we'll write down the method. What's our method? Hang the magnet on the stand according to the figure, according to the figure. So according to this figure, we need to hang the magnet, right, on the stand. Allow it to rotate and align with a certain directions. Align with certain directions. Align with certain directions. So this is our method. So we need to hang the magnet by using the stand and using the thread. Then we need to allow it to rotate and align with certain directions like this. So I have marked X and Y terminals here. I have marked the two terminals X and Y. So this is the north direction. You can observe in the figure the north direction. So if that end is the north, then we know that this is the south direction. This is the south direction, right? If you know that is the north, then we know that this is the south direction. The two terminals or the two directions are opposite to each other, no? So if that thing is the north, then opposite direction is the south. So finally, this magnet will align on north and south directions. The terminal which is at the north direction is the north pole of the magnet. Terminal which is at the north direction in this magnet, that is the north pole. Okay, terminal or the end which is at the north pole is the north pole of the magnet. Terminal which is at the south direction or south pole of our earth, that is the south pole of the magnet. That is the south pole of the magnet. So my dear children, so this is our method in conducting the activity. So we'll go to our laboratory and we'll see how to conduct the activity. Right, my dear children. Now let us find out another way in identifying the poles of a magnet which are unknown. So here you can observe a magnet with unknown poles. So I have hung that magnet by using a thread on a wooden stand. See, this is a wooden stand. By tapping you can observe it. This is a wooden stand. It's not made up with metal. Why it is important to use a wooden stand is, so here if I am going to use a material made up with a magnetic material like a metal, so the magnet will attract towards this thing or the towards the stand. So in that kind of situation, we can't get the observations or the desired observations very accurately. So it's wise to use a wooden stand like this when we are conducting experiments related to magnets. So now let's identify a special feature regarding the magnets. So now I have a magnet which hung freely, and also I have a compass with my hand. So you can see when you observe this compass, now the compass needle is pointing, the red color needle is pointing that direction, means it's the north direction of our earth. So here you can observe the compass needle. So the compass needle is pointing towards the north. So this is the north direction of our earth. That direction is the north then. That direction is the north. So I'm going to keep the compass like in the same way, right? Then this is my magnet. This is the magnet which hung freely, right? So now I'm going to held it in my hand. So I'm holding it in my hand. So now I'm going to release it. Let's see to which direction does the two terminals turn. So now I have released it. So it's rotating here and there. So here, so I have given a small bit of a push and now it's rotating here and there. Let's see at which end or to which direction does this magnet going to finish its rotation. Right now, my dear children, you can observe that the rotation of the magnet has stopped, and you can observe this terminal of the magnet is pointing that direction, and same as the pointer of the red color pointer of the compass is also pointing that direction. So it's obvious to us this terminal of the magnet should be the north terminal and the other one is the south. It's because that when you keep a free suspend magnet like this, always the two terminals are pointing or they would align in north and south directions of our earth, like in the compass. So here when you take the compass, you can observe the compass needle is always pointing towards the north and south directions. So that's a common property in magnets. If you hung a magnet freely in our environment like this, always the two terminals is going to show the north and south directions. So the terminal which turns towards the north is the north pole and the terminal which turns towards the south is the south pole. So by using the compass also we can conclude our observations. So this pointer is showing the north direction and this point is also showing the north direction. So this terminal is the north and the other terminal is the south. So by that way we can conclude the two terminals of a magnet that has unknown poles by hanging it or by releasing it in the environment like this way. Now by hanging it by using a thread, we can identify the two terminals of identify the two poles of a magnet by hanging it like this. Dear children, I think we have completed that activity. So from that activity we can observe, we took an observation. So what is that observation? It's really simple. The two terminals of the magnet will align in north and south directions, right? The two terminals of the magnet or else two ends of the magnet will align in north and south directions, right? So that was our observation. So finally, in our conclusion, we can write the direction or the terminal that shows the north direction or that turns to north direction is the north pole of the magnet. The terminal which turns to south direction is the south pole of the magnet. Right. So we'll write down the observation and conclusion from this activity. Right. So our observation is two terminals. Terminals means ends. Two ends. So two terminals of the magnet will align to north and south directions, to north and south directions of the earth. So this is the observation. So we took this observation. The two terminals of the magnet will turn to north and south direction of the earth, right? So in our conclusion we can write, terminal that turns to north direction is the north pole, terminal which directed towards the south pole is the south pole of the magnet. So this is how we can observe the north and south poles of a magnet by using a thread and by hanging that magnet by using that thread on a stand, right? So in here we can say that this magnet is behaving like a compass. This magnet is behaving like a compass. In compass also we can observe the same procedure or the same mechanism, right? So we can write finally, terminal on the north direction is the north pole of the magnet. Is the north pole of the magnet. Right? So terminal on the north direction is the north pole of the magnet. Then the terminal on the south pole I'll use the south direction. So south direction, terminal on the south direction is the south pole, of the magnet. Right then. So this is our final conclusion from the activity, right? So by using this way also we can identify the unknown poles of a magnet, right? Here we use the mechanism that is equal to the compass, right then. So we'll find out another ways to identify the two poles of an unknown magnet, right? So here we are going to discuss another way of finding the poles of an unknown magnet. So here you are given with finding magnetic poles considering the direction that magnet turns when it is floated on water using a piece of cork or styrofoam. Styrofoam means regiform. You have heard about regiform, no? Regiform. Styrofoam means regiform. Regiform, right? So that is styrofoam, right? Here also we use the same mechanism which is equal with the compass. But instead of hanging, we can use a water basket and we can place the magnet on that water basket, right, by using a piece of styrofoam or else a cork, right, so that it would not drown and it will rotate on water. Then once again the magnet will align clearly between north and south directions of the earth, like in the earlier case. In the earlier case we hang the magnet, but here we are going to float it, right? So in both of these occasions it would align to north and south directions perfectly, right? Okay, so we'll see how to conduct this activity. So materials needed, you'll be needing these materials: bar magnet with unknown poles, then piece of styrofoam, or else rigiform. Then you need a basket of water. You need basket of water. So these are the materials which you need. You will be needing these materials. What are the materials? You will be needing a bar magnet with unknown poles, piece of styrofoam or else a rigiform piece, or else then next a basket of water, right? Basket of water. So if you don't have a piece of rigiform, you can use a piece of cork, but it's easy to find a rigiform piece rather than a cork, right? Okay. So these are the materials which we need. So we'll see how to conduct this activity then. So this is the figure which related to the activity. So you can observe clearly, right? Here you can observe clearly. We keep the rigiform piece on water. Then after that, we are placing the magnet on the rigiform sheet, right? Very carefully, like this in the figure. Okay. So finally, the magnet will turn, or it will rotate and align in two directions. Okay. So those two directions are the north and the south directions of our earth. So the terminal that is on, or that is getting directed towards the north direction, is the north pole of the magnet, and the terminal which is getting directed towards the south direction is the south pole of the magnet. Okay, so we'll write down the method then, how to conduct the activity. The method: place the rigiform piece on water basket. Then in the next step we can write, you have to place the rigiform sheet on the water basket. Then after that, place the magnet carefully. Carefully means make sure it would at the center, it is at the center. Make sure it is at the center. If it is not at the center, then the magnet will drown, right? Then the magnet will drown. So remember, we need to keep it at the center like this in the figure, right? So that it would balance. Okay, right. So place the magnet carefully on the rigiform sheet and allow it to rotate and align and aligned between directions and align between directions. Right there. So this is how to conduct the activity. First of all, place the rigiform piece on water basket, then place the magnet carefully on the rigiform sheet and allow it to rotate and align between directions, right? So in the figure also you can observe the steps, right? Now we'll move on to our laboratory to observe this experiment, right? So we'll see what kind of things, what is going to happen when you are conducting the experiment. Right, my dear children. Now let us investigate another method how to find out the poles of this unknown magnet in here. So this magnet also, an unknown magnet, means that we don't know the poles of this one. So by using another method, now in here also we're going to freely suspend this magnet, but I'm not going to hang it, but I'm going to float it in this water basket. Now you know that when a magnet is freely hung or freely rotated, it's going to turn to north and south directions. You know that. So I have a compass in here. So you know that if you take the compass, always the two terminals of the compass, the needles of the compass is going to turn to north and south directions, as it is also a type of a magnet which pivoted freely on this metal or the steel case. So here you can clearly observe that direction is the north and this direction is the south. That direction is the north and the opposite direction is the south. So red color pointer is pointing towards the north. So I'm going to keep the magnet, keep the compass in this position like this. Now I'm going to take my unknown magnet. So instead of, so I have used a styrofoam or else a rigiform board so that I can keep the magnet without sinking in this water basket. So now what I'm going to do is I'm going to place this magnet I'm going to place this magnet on the water basket and let's see whether the two terminals is going to show north and south directions. So I'll take it to the middle once again. So it will float and eventually will turn to north and south directions. So I'll take once again towards the keep it in like this kind of a position, and let's see whether it's getting turned towards the north and south directions. Okay, right. So my dear children, I have turned the magnet to this kind of a direction, and still it turns this kind of a direction and always pointing towards that direction. And you can observe when you take the compass needle is also pointing that direction, and this terminal of the magnet is also pointing that direction. So means that it's quite obvious to us, this terminal which turned towards the north direction of our earth, so this terminal is the north pole, and the terminal which turned towards the south direction this way around is the south pole of the unknown magnet. So each and every magnet which rotates freely or which hung freely in our environment ultimately turn towards north and south directions. So by using that property, we have found out the poles of this unknown magnet. So here we use a water basket and we float and we float the magnet by using a styrofoam board or else a regiform board. So this is how to identify the poles of a magnet by floating it in water. So let us investigate another method in finding out the poles of an unknown magnet. Right, my dear children, so we conducted the activity at the lab. So you could observe that the terminals of that magnet is going to turn towards north and south directions. By using a compass also, we have concluded it, right? So we'll write down our observation and our conclusion, right? Take the terminals of the magnet. Terminals of the magnet align to north and south directions. So here also we could observe that the terminals of the magnet align to north and south directions, right? Then the conclusion, right? Then our final conclusion we can write like this. Our final conclusion is the terminal which is at the north direction is the north pole. Terminal which is at the south direction is the south pole of the magnet, right? So here we can write so I'll take the slide somewhat up to write the conclusion. So what is our conclusion? This is our final conclusion then. Terminal at the north direction is the north pole of the magnet. Then terminal at the south direction is the pole, south pole of the magnet. So this is our final conclusion from the activity, right? So I told you that in these two cases, in the early activity as well, when we used to hang the magnet by using a thread, and in this activity also, when we used a piece of regiform to float the magnet on water. So in both of these occasions, we use the behavior of a magnet as the behavior, or which is similar to the mechanism in a compass, right? Always, all the time, magnets are going to turn to north and south directions of our earth if they are freely hung, right? So we'll see another way, a different way to find out the directions or the poles of a magnet if you are given with unknown poles, right? So we are discussing another way, right? We are going to find out the poles of a magnet by using a different method in this activity. So here we are discussing finding magnetic poles by observing the attraction or repulsion when a magnet with known poles is brought closer. Now we need a magnet with known poles. We need a magnet with known poles. Okay. So by using this magnet, we can find out the poles of this unknown magnet as well. We can find out the poles of this unknown magnet. Right. So we'll see how to conduct this activity. So you'll be needing these materials. What are the materials? First and foremost, you need a bar magnet with unknown poles. Bar magnet with unknown poles. Then you need a bar magnet, but here in this case, this bar magnet should be a bar magnet with known poles. Okay, right. So the second one, you need a bar magnet with known poles. Once again, you will be needing a piece of thread. You'll be needing a piece of thread and a stand. So these are the materials you would need. You need a bar magnet with known poles. You'll be needing a bar magnet with unknown poles. So this is the unknown poles thing. This is the known poles thing. You'll be needing a bar magnet with unknown poles. You'll be needing a bar magnet with known poles. Then a piece of thread. The piece of thread is used to hang the magnet. And finally, the stand. Finally, you will be needing a stand to fix the magnet. Okay. So we'll see how to conduct this activity then. So it's really simple. If you want, you can hang the unknown magnet like this, or else you can hang the known magnet. Okay, you can do either of these two ways, right? So here in the figure, now you can observe that the hang magnet is the unknown pole magnet. Okay, so in the method also I'll mention the thing which is given in the figure, but remember you can use the other way around also, right? So we need to hang one of these two magnets by using a thread on the stand. Okay, right. So here in the figure, you can observe that in the figure it is given the unknown magnet or the bar magnet with unknown poles is the one which is hung on the stand. So I'll mention that thing in my method. Okay, so first thing to do is hang the magnet with unknown terms with unknown terminals, so unknown poles. Hang the magnet with unknown poles on the stand using the thread. Next point. So in the next point, in the next step, what we have to do? We have to bring near the other magnet to the terminals of the unknown magnet like in the figure. Okay. So here in the next step, bring near the north pole of the other magnet to a terminal, to an end. I'll use the end, to an end of the hung magnet. Right? So bring near the north pole of the other magnet to an end of the hung magnet like this. So we'll be bringing this north pole to the hung magnet, right? The next step, bring near the south pole, of the other magnet to the same end of the hung magnet. And observe. So here, this is the way of conducting the experiment. So this is the way of conducting experiment. First of all, you have to hang the magnet with unknown poles on the stand using the thread, or else in the other way around also you can do this activity. You can hang the other magnet which has the known poles by using a thread, right? So in the next step, bring near the north pole of the other magnet to an end of the hung magnet. So you take the north pole and you keep the North Pole on one terminal or one end of the hung magnet. Okay. Then bring the South Pole of the other magnet to the same end of the hung magnet and observe. Right. Conducting this experiment to one end is enough, because by taking those observations we can predict, or we can conclude what are the two terminals or what are the two poles of the unknown magnet. Conducting this way around to just one terminal is enough. So by identifying one terminal, we can identify the other as well. So this is the way of doing the experiment. Now we'll move on to our laboratory and we'll observe what are our observations, right? Right, my dear children. Now let's find out another way of finding out the poles of a unknown magnet like this. So once again I have hung the magnet, the poles with unknown, the magnet with unknown poles. See this magnet, I have hung it by using a thread on this wooden stand, right? So let's identify how or what are the north and south poles of this unknown magnet. So now in this situation, I am going to use another magnet. Now in this magnet, we know what are the north and south poles. So the area which colored with red color is the north pole, and the area which colored from blue is the south pole. Right, my dear children? Now let's see, or let's observe whether the above statement is true or not. So I'm going to take another magnet and I'm going to show you that the north pole and the north pole, or else the south pole and the south pole, means the like poles are going to repel each other, and the unlike poles like north south and south north are going to attract each other. So I'm going to take another magnet and we'll see whether the above statements are true or not. So I have another magnet here, the second magnet. Now I'm going to take this south pole towards the south pole of this magnet. So it's clear to us that there is no attraction, right? There is no attraction. Now I can feel it in my arm. They are repelling each other, right? See here, they repel each other. See, can you see that? They repel each other. The magnet will easily rotate to the other side. See, can you see that? So now I am going to take this red color terminal towards this blue color terminal, and let's see whether it is getting attracted or not. So it's clear to us that these two are getting attracted quite easily. See, if I am going to take the other terminal, the north terminal towards the north terminal, once again, see, those two terminals are getting repelled each other. See, so always you can observe the unlike poles are getting attracted each other, and the like poles, they would repel each other. See, they are like unlike poles are always, these poles are always repel each other. You can observe it. And now by using that feature, right, we are going to find out. Now I'm going to keep this other magnet, the second magnet, away. Now I'm going to have this magnet and bring this south pole towards one terminal of this unknown magnet. So if that terminal is getting attracted to the south pole, then that attracted terminal of the unknown magnet is the north pole. When I'm going to take this north pole towards the one terminal of the unknown magnet, if it is going to repel each other, then that terminal is also a south pole. So by using that feature, let us find out the poles of this unknown magnet. Okay, now I am going to take this magnet, the south pole of the magnet, towards the now see here, you can observe the south pole is getting attracted towards this terminal. Means that this terminal which is attracted towards the known magnet should be the north pole. So this is the north pole of the unknown magnet. So if this terminal is the north pole, then the other terminal, this one, is the south pole. So let us conclude that pole as the south by interchanging the two terminals of the known magnet. So let's interchange and see whether the other pole is getting attracted towards the red area. So I'll keep my finger like this. So this is the other end. This is the end which attracted towards the south pole. This one, see, once again you can observe it. So I'll keep my finger like this. And now I'm going to take the red terminal, the north pole. And now let's see which terminal is getting attracted. See? So a magnet rotates and turned away, then once again it came back and the other terminal got attracted. So it's clear to us. We can identify the two terminals of this magnet by using this known magnet. So by the attraction and by the repulsion of the known magnet with the unknown magnet, we can identify the two terminals of this unknown magnet. So if the north pole is attracting, towards one pole, then that pole is the south of the unknown magnet. And if the south pole is getting attracted to this magnet, to a certain pole of a magnet, pole of this magnet, then that pole is the north pole of this unknown magnet. So by using that simple attraction theory, we can find out the poles of this unknown magnet. So we'll find out another way in finding out the poles of this unknown magnet by using a different way, by using another way. We did our experiment and we observed certain important observations. So we have discussed earlier, same poles of a magnet will definitely repel each other. Same poles, like poles of a magnet will definitely repel each other. Different poles, when same poles are repelling, different poles will definitely get attracted to each other, right? Same poles will repel, different poles will attract. So I'll show, this is my hung magnet. I don't know the poles of it. So when I'm going to bring north pole of the magnet, and if in this situation these are getting attracted, then in this situation we can say that this unknown pole is the south pole of the magnet. It's because that if they are getting attracted, then definitely north pole is getting attracted to a south pole. So this is the south pole. Definitely this pole should be a south pole. So if this thing is south pole, then the other should be the north pole. So if this is the south pole, then this is the north pole. So by that way we can identify the two terminals or the two poles of the unknown magnet. Okay, so I'll keep the figure in the same way and I'll write the observation. So my observation is one end is attracted to the north pole of the non-magnet So one end is attracted to the north pole of the non-magnet. One end is attracted. So we can say to the south pole that end is showing a repulsion. So to the south pole that end is showing a repulsion. One end is attracted and the same end is showing a repulsion to the other pole. Okay. So here one end is attracted to the north pole of the non-magnet. To the south pole that end is showing a repulsion. This is our observation. So by that way, according to the figure, we can conclude the two terminals of the unknown magnet. So we can write in the conclusion like this then. You can write like this. So our conclusion is finally north pole is attracted to the south pole of the unknown magnet. To the south pole of the unknown magnet, right? So in the next case, we can write other end of the unknown magnet is the other end of the unknown magnet other end of the unknown magnet is the north pole. So this is our final observation. So here north pole is attracted to the south pole of the unknown magnet. Always the north pole is getting attracted in the non-magnet to the south pole of the unknown magnet. So by that way we can identify the south pole of the unknown magnet. Then in the next case, the other end of the unknown magnet then is the north pole. Other end is the north pole, right? So this is the way of conducting our experiment and how to come into conclusions by using the observations. So it's really simple. We took a magnet, we took two magnets, one with a known poles and the other one with unknown poles. So we brought near the known poles with the unknown poles of the unknown magnet. So through the attraction and the repulsion, we found out the unknown poles of the unknown magnet, right? So this is the way of conducting the experiment. Now let's examine another way to find out the two terminals or the two poles of a magnet that has unknown poles. Unknown poles means, once again, here the poles haven't been marked. So if the poles are not being marked, how to identify the magnetic poles, right? So this is our next experiment. So we'll move on to observe another experiment on how to identify the magnetic poles of a unknown magnet. Okay, so in this experiment, we'll be finding the magnetic poles by observing the direction that the magnet turns when it is kept on a watch glass and moved freely on another watch glass. So here we need to place this unknown magnet that we have on a watch glass, and we need to place it on another watch glass so that it will rotate quite easily around the first watch glass, right? You can place watch glasses on top of each other like this. This is the first watch glass, this is the second watch glass. So you can place it like this. So it will rotate like here and there like this. So I can draw it to you. This is my first watch glass. I'm going to turn it inward like this and place the other watch glass like this. So when I'm going to place the other watch glass like this, it will rotate and turn here and there quite easily. So before that, we need to place the magnet, or else if you want, you can place the magnet even after placing this watch glass together like this. Then I'll mark the magnet by using this blue color. So this is my magnet, that unknown magnet. So we need to turn it. So we need to place it and allow it to turn. But before that, we need to identify which direction is north and which direction is south. No. So to identify that north and south directions more accurately, we need to use this bar magnet which has known poles, or else you can use a compass to get more accurate and more distinct observations, right? You can use a compass. You know that if you take a compass is also behaving like a magnet. Actually, it is a type of a magnet. It's a freely pivoted magnet, right? So you can place a compass. Don't keep the compass near these magnets, because these magnetic fields can affect these magnetic fields can affect the magnetism or the rotation of a compass, because compass is also contained in a magnet. Okay, so you can either use a compass or else you can use this permanent magnet with known poles, right? First, so here we'll use the permanent magnet, right? And we'll conduct the activity, and to make sure that I'm going to take more accurate answer, we'll use a compass as well. So first of all, we'll write down the materials that we need. So what are the materials, my dear children? So the materials are, first of all, you'll be needing magnet, with unknown poles. Magnet with unknown poles. Then 2 watch glasses. Right. 2 watch glasses. two watch glasses. Then finally, a bar magnet. A bar magnet with non-poles. Bar magnet with non-poles. Bar magnet with non-poles. So these are the materials which we need. Magnet with unknown poles here, two watch glasses and a bar magnet with unknown poles. Okay, so to make more accurate answers, or to make more to get more accurate observations, you can use a compass. So a compass to get more accurate observations. Right? So this is only if a compass is available. Okay, if not, you can carry out this experiment by using these materials as well. Right, my dear children, then let's move on with the next slide and we'll see how to conduct this activity. Right? Okay. So in here the figure is given. So by looking at the figure, you can see how to conduct this activity. So we just need to take a watch glass and place the other watch glass on top of the first watch glass like this. Then we need to keep that bar magnet according to the given figure first and identify the directions of north and south poles. Okay, we need to identify the directions of north and south poles. Means that in the first instance we have to use the bar magnet that has known poles, and we need to place it like this, and we need to identify to which direction does the north pole is going to turn and to which direction does the south pole is going to turn. Then after that, by removing the first magnet, we need to place the second magnet which has unknown poles like this. Okay, and we need to allow this watch glass to freely rotate. Then after that, the watch glass will align in two different directions. So by the earlier observations, we can write down, or we can find out, by using the earlier observation, we can find out the north and south pole of the unknown magnet. Right, so we'll write down the method, my dear children. So first of all, take the magnet with known poles and place it on the top of the first watch glass according to the figure. According to the figure, right? So according to the figure, here the figure is given, my dear children. So you have to place the two watch glasses like this, and you need to place that magnet that with non-poles like this. So it will turn and align in two different directions. then we have to identify to which direction does the north pole is going to turn and to which direction does the south pole is going to turn, right? So we have to identify it and we have to mark it down. So first of all, take the magnet with non-poles and place it on the top of the first watch glass according to the figure. So I'll mark the two watch glasses. This is the first watch glass. I'll use a different color to mark the second watch glass. This is my second watch glass. Right. Then the next step. In the next step, we need to identify to which direction does the north pole is going to turn and to which direction does the south pole is going to turn in this setup. Okay. Identify and note the directions. Identify and note the directions which the poles of the magnet, which the poles of the magnet turn into. So in the next step, we need to identify and note. We need to identify and note. Means that you have to take, you can take a small bit of a note or else you can memorize, right? Because we are conducting this activity in a short time period, no? So we can memorize to which direction does the north pole is going to turn, right? So identify and note the directions which the poles of the magnet, which the poles of the magnet. Identify and note the directions which the poles of the magnet turns to. Okay, right? So the magnet is turned into two different directions. I mean, like when you take the two poles of the magnet, it's going to show or it's going to align in two different directions. So we need to note down those two directions, right? So identify and note the directions which the poles of the magnet turns to. Okay. Then in the next step, place the magnet with unknown poles place the magnet with unknown poles and place the magnet. So we'll write it like this. Replace the magnet, right? Replace the magnet. So I'll erase. We'll write it like this. Replace the magnet with unknown poles. Replace a magnet. Replace the magnet with known poles. Replace the magnet with known poles by using the magnet with unknown poles. Find out the directions, find out the directions which the system, which the terminals, find out the directions which the terminals of the magnet. So finally we need to find out the directions which the terminals of the magnet aligns. Right. So this is the way of conducting the experiment. So we'll once again see how to conduct this. First of all, we need to take the magnet with known poles and place it on the top of the first watch glass according to the figure. So like this way, we need to place two watch glasses on top of each other, and we need to place the magnet with known poles first. Okay. So take the magnet with known poles and place it on the top of the first watch glass according to the figure. Then after that, we need to allow it to rotate freely, and we need to observe to which direction does the north and south pole of the magnet is going to turn. And we need to note it down, or we need to memorize it. Okay. So second step, identify and note the directions which the poles of the magnet turns to. Okay. In the third step, we need to remove, or we need to replace that magnet with known poles by using the magnet with unknown poles. And once again, we need to find out the directions which the terminals of this unknown magnet aligns. Okay. So this is the way of conducting the activity. So we'll head on to the lab and we'll see to which directions does the poles of this unknown magnet aligns to. Right, my dear children. Then we'll observe another method, or we'll conduct another activity to find out the poles of a unknown magnet like this. So here also we going to freely suspend this magnet, but in this occasion we use a watch glass. So watch glass is a glass made like this, right? This is the one which is referred as the watch glass. So it has a concave and a convex shape. This is a concave one and this is the convex shape. So now what I'm going to do is I'm going to take another watch glass like this, which is held inverted, and I'm going to place it, the second watch glass, like this, so that it would rotate around second watch glass quite easily. See, so it's rotating around the second watch glass quite easily. And now I have a magnet which we don't know the poles. See, this is the magnet which we don't know the poles, and now I'm going to place it on this watch glass. Right, now let's see another time whether the expected observation could be observed or not. So I have placed the magnet like this. So let's see whether it is getting turned towards the desired direction or not. So once again you can see the magnet which placed on the watch glass has turned to this direction, And also I have a compass in here. So you can see the compass needle is also pointing towards that direction. So means that here you can observe the red color of the compass. So it's showing the north direction, and this terminal also pointing towards that direction, which is same as the north direction of our compass. Means this terminal which turn towards that red color region of the compass should be the north terminal. So you can take a small bit of a sticker or else a paint, and we can put a paint like this. So this is my north pole of the magnet. So I'm going to place it again so that you can observe the turning direction very clearly. See, always the north pole is going to turn towards the north direction, same as the compass. So this is my north pole of the magnet, and the opposite pole is the south pole. So these are the ways of identifying magnetic poles if the poles are not marked on this magnet. So this magnet is a magnet that has unknown poles. So we discussed several ways in finding out the poles of this unknown magnet. Let us further discuss what are the things which are related to our lesson then. Right, my dear children. So we conducted the activity, right? So in the earlier case, I told you when I was doing the method, I told you that we need to take a permanent magnet or else a bar magnet when conducting this activity, right? But when I am doing the activity at the lab, I used only a compass, right? So it is quite easy to conduct this activity only by using a compass. You already know that compass is also a type of a magnet, right? So instead of that bar magnet, it's we don't have any kind of a problem to use a compass, right? So compass is also a type of a magnet that we can use to find out the directions. Okay, so here we can use the compass like in the earlier activity, right? Like in the earlier activity, we can find out the directions by using the compass, right? So here when I'm doing the activity, I didn't use the permanent magnet, I used only the compass, right? Okay, so we'll write down our observations. So how to get our so we did our experiment and we got the necessary observations. Okay, so we'll write down our observations and let's write down our conclusion as well from this experiment. So my dear children, our observation was quite simple. So what has happened during the experiment was, right, the poles or the terminals of the unknown magnet turned to north and south directions of the earth. How did we find out the north and south directions of the earth? It's by using the compass, right? Okay, so we can write it like this. Terminals of the unknown magnet will align with the same directions, will align to north and south directions of the earth. Okay, will align so terminals of the unknown magnet will align terminals of the unknown magnet will align to north and south directions. Right? So terminals of the unknown magnet will align to north and south directions. Okay. So what is our conclusion from this activity? So our conclusion is quite simple. The terminal that turn to north direction is the north pole. Terminal which directed towards the south pole, terminal which directed towards the south direction is the south pole. Okay, so the terminal which is directed towards the north is the north pole. Terminal which is directed towards the south is the south pole. So our conclusion finally, terminal which turned to north, terminal which turned to north is the north pole. Of the magnet. Terminal which turned to south pole, south direction, right? Terminal which turned to south direction is the south pole. Of the magnet. Right. So this is our final conclusion from the activity. The terminal which turned to north is the north pole of the magnet. Terminal which turned to south direction is the south pole of the magnet. So I told you in the earlier case also, when I was starting this activity, right? It's quite easy to get these observations when I'm going to use a compass. So when I'm doing the activity at the lab also, I used a compass instead of the bar magnet, right? Okay, my dear children. So this is the final way of finding out the terminals or the poles of a magnet if they have not been marked on a certain magnet, right? So we'll discuss further things related with our lesson in our next chapter.